The average number of students per classroom Y at Central High School can be estimated by using that ugly, terrible equation right there. X represents the number of years since 2004, and X has to be less than 10 or equal to 10 for some reason. I guess I don't care about 2005 or whatever. Which of the following statements is the best interpretation of that number in the context of this problem? All right, well, so that number, 0.8636, is the slope. Okay, the slope when you're talking about a word problem is also known as the rate of change. That's supposed to be an F. The rate of change. Now, what the rate of change stands for is slope is rise over run. So the rate of change is the change of the Y values over the change of the X values. Right? My Y values is students per classroom, and my X values is the number of years as time goes on. So basically, what this is saying is, even though it says that X can't be 0, but if we were to start at 0, right now there's 27 kids per classroom. And then we add an eighth of a student at the year after that. And then we add another eighth of a student, and so on and so forth and so on and so forth. So this is how many, or what the increase is over time in students per classroom over the years. So this number itself is not the average number of students per classroom. What A is saying is we are estimating that there are 0.86 kids in the classroom. No, what kind of class has 0.8 kids? So B doesn't make sense either, because B is saying that there's 0.8 kids in 2014. No. C mentions the estimated yearly decrease in the average number of students per classroom. Now, that would make sense if this was negative. Decrease means your slope is negative, you're going down. What we have is an increase, since that's a positive number. Every year, we add a little bit less than one kid per classroom, so the answer is D. Be careful of the wording. That's how they get you here. It's the wording that's the trickery.